This video is for the product case study of the Black & Decker citrus juicer CJ630. The study and video are provided by Carlos Franco, Diana Lee, Suhail Arafat, and Kevin Sung for the Spring 2017 ME110 manufacturing processes course.
We have taken apart the citrus juicer to inspect the individual components and determine which possible manufacturing processes were used in their creation of 3 parts. Possible alternative manufacturing processes for these parts will also be explored, and the working principles of GD&T will be discussed and how it would affect the product assembly.
The first part that we will talk about is the plastic base support. The possible manufacturing process used to create this part was determined to be injection molding. This can be seen by the evidence of imperfections like this flash and divots left over from the die. Another reason is the evidence of seams and flow lines around the perimeter. The plastic has also been molded with a constant thickness. Injection molding is used for complex shapes and mass production. It has high production rates and produces good dimensional accuracy. Another possible process used is compression molding. In this process, a flash is formed, but removed using trimming or grinding. Evidence of this may be the tool marks on the bottom edge of the base. However, this process requires less complex shapes and uses expensive tooling. The dies are generally less expensive than injection molding because of less complex shapes. However, undercuts are not recommended.
The switch shaft makes contact with the prongs. The user applies pressure to the extractor cone, allowing conduction of electricity to power the motor. Within the switch is a spring that returns the switch back to its natural state, which is the state in which electricity cannot be conducted to the motor. The manufacturing process of the shaft was machined through turning with a lathe. This is evident due to the nip formed at the center of the surface when faced. Additionally, chamfering on the edge of the shaft could have been made through the turning process. The prongs were most likely manufactured by stamping and then sheet metal formed. Prongs were most likely stamped because of its flat profile and uniform thickness, followed by bending of the sheet metal.
The pinion gear tooth that is fixed to the motor shaft was determined to have been manufactured through a broaching process. Physical aspects that lead to this conclusion were high dimensional accuracy and good surface finish. Other inferences that contributed to this decision include the fact that the manufacturing of these gears are done in high production quantities. The gear could have also been made through a hobbing process in which the gear teeth are individually cut by a rotary hob. While hobbing in general is less expensive, this is very unlikely due to the need for high quantity production needed for the part as well as its small size.
Here's an example of an important tolerance. Location and orientation are particularly important for this component. If either the shaft toe for the large gear or the shaft itself is not oriented properly, meaning perpendicular to the bottom planar surface, the motor pinion gear will not mesh with the large gear, rendering the appliance worthless. Similarly, if the location of the features such as the shaft toe are not located correctly with respect to the motor, then a similar failure will occur and the part will have to be discarded.
This concludes our case study video for the Black & Decker citrus juicer.